मॉर्निंग दोस्तों, मेरा नाम सुरेंद्र कुमार है और मैं अजय कुमार इंजीनियरिंग कॉलेज में असिस्टेंट प्रोफेसर पर हूं और मेरा डिपार्टमेंट है कंप्यूटर साइंस एंड इंजीनियरिंग। तो आज हम बात करने वाले हैं थ्योरी ऑफ लॉजिक, जो कि यूनिट 3 से कंसर्न करता है और सब्जेक्ट है डिस्क्रीट स्ट्रक्चर एंड थ्योरी ऑफ लॉजिक। सो थ्योरी ऑफ लॉजिक basically works with those topic where we want to process our natural language. So how language is processed in computers? So this we will study in this type of topics. So there are some main points how to use the theory of logic and what are the subject content of this topic, that is proposition, truth tables, tautology, satisfiability, contradiction, algebra, proposition, theory of inference. So these are topics for this. With this we have some predicate logics also, in which we are using first order predicate, val form formulas of predicate, quantifiers, inference theory of predicate logic. So today we will discuss about the theory of logic. So theory of logic, student will learn basically here to represent English language statement using symbolic logic notation. So the main purpose of our topic is to convert your language into symbolic notations. So use and interpret rational conjunctions that are and or and not, XOR, in terms of quotients, if and then, and equivalence relation, if and only if. So with this we use truth tables to analyze the truth values of the compound statements based on the truth values of the component. So use truth table to determine if two statements are logically equivalent. Again use truth table to identify tautology and contradiction and contingency. So these are the roadmap and what is the outcome of this topic. Prerequisite, as usual, you have some knowledge about set theory, relation and functions. Now what is proposition? So proposition is a declarative statement which is either true or false. So it is a technique of knowledge representation in logical and mathematical form. So what is knowledge? Knowledge, whatever we share the information with the others, is called our knowledge, and this knowledge has to be represent in a logical and mathematical manner. For example, we have it is a statement, it is a Sunday. So again it's a knowledge and we represent it in English language. The sun rises from west. It may be false, but the statement is 3 plus 3 equals 7. It's again a false proposition, but it's a proposition. 5 is a prime number, again a statement or proposition. So if we talk about the types of proposition, there are basically two types of propositions in our study. First is atomic. So atomic and compound, as the word suggests, atomic means a single statement, a simple proposition is called an atomic proposition. It consists of a single proposition symbols. These are the sentences which must be either true or false. The condition is these statements should be either true or false. If we take an example, 2 plus 2 is 4. It is an atomic statement as it is a true fact. Again we take another example, the sun is cold. So we all knows the sun is not cold, so it is a proposition, but it is a false fact, but still it is a proposition. So these two are the atomic propositions. Now we come to the compound proposition. They are basically constructed by combining simpler or atomic proposition. So, using parenthesis and logical connectives will help us to combine these atomic statements to prepare any compound proposition. Here we take an example A. It is raining today is an atomic statement or proposition. Street is wet again is a atomic proposition. But if we combine with the conjunction this symbol and, right, so this will be now a compound proposition. So we are combining it is raining today and street is wet. Complete statement is now compound statement. We take example 2. Ankit is a doctor again is a simple proposition or atomic proposition. Second one is his clinic is in Mumbai, again is atomic proposition, but we are combining with the and, then it will be work as a compound proposition. So I hope you understand the difference between atomic proposition and compound proposition. Now, what are the basic operations, or you can say what are the basic logical operation on these kind of propositions. So already we have studied in previous classes about the logical operations. So basic logical operation operators, or you can say these are the logical connectives, are used to connect simpler proposition or representing a sentence logically. We can create compound proposition with the help of these logical connectives. So they are mainly 5 connectives we use here. The first one is negation. So a sentence such as negation P, this is the symbol for negation. You can use this kind of symbols also. Many books have different symbols, and so before placing this kind of symbol, it will be work as a negation of P. So a literal can be either positive literal or negative literal, right? So we can create positive literal to negative with the help of this connective negation. Second one is conjunction. A sentence which has this kind of symbol is called conjunction, or it can be written as P and Q. It is read as P and Q. P conjunction Q. Example is there. Rohan is intelligent and hardworking. This statement can be represented with the help of symbols, like we place Rohan is intelligence with P and hardworking. Rohan is hardworking by Q. We have converted these 2 atomic statement into 2 symbols, notations P and Q, and this P and Q will work now as connected with and symbol. It will be like that P and Q, P conjunction Q. Clear, students? The third one is disjunction. Disjunction is a sentence which has this kind of connectives, or you can say it is or. This is and this is or. Like you write P or Q is called disjunction. We take an example. Ritika is a doctor or engineer. Again, we break this compound statement into atomic statement and give the symbol of every atomic statement, like we have written P as Ritika is a doctor and Q as Ritika is an engineer. Here it will be engineer, right? So we can write it. Here we have or word, so we can write P disjunction Q, P or Q. Next one is implication. Implication basically works with sentence such as P implies Q. Is called an implication. That implications are also known as if then rule. This implication is if then rule. So, for example, we have if it is raining, then the street is wet. So, if then, so such kind of proposition, compound proposition will be converted with the help of this implication symbol. So, again we have break up it into atomic statement. P, it is raining, Q, street is wet, and you can write it P implies Q. This means if it is raining, then the street is wet. Again, there is one kind of condition also where we have if and only if. For this we are using biconditional preposition connectives. Sentence such as P double implies Q, you can say it is a double implies also, is biconditional sentence like if I am breathing, then I am alive. Or you can say if I am breathing, then if and only if I will alive. Yeah, I am alive. So, you can write it as P, I am breathing, Q, I am alive, or you can write it because if you are alive, it is satisfying from property from both sides, not a single side. If I am breathing, then I am alive, or you can say if I am alive, then I am breathing. Both the condition is satisfied from both the sides. That's why this is a double implication, like biconditional statements or proposition. I hope you have understand all the 5 propositions, 5 kinds of propositions, operators. So, this is the summary of the given connectives or operators and or implies if and only if and not negation. Now, what is a truth table? So, truth table is basically is for examine the logical operations with the help of these operators: negation, conjunction, dissection, exclusive or implications, biconditional. And the truth table can be used to show how these operators can combine proposition to compound proposition. So, unary negation is basically a unary operator because it works on single operand and the symbol is negation. This is the symbol for negation. Or if you negate some statement and it is true, after negation it will be false, and if it is false, then after negation it will be true. So, it is basically one kind of complement relation. If we talk about the conjunction, conjunction basically is a binary operator. It works on 2 operands and it is symbol is this, and the truth table for the symbol is if both are true, it is true. If any one of them is false, it is false, or if both are false, then again it is false. That means it will be only true if and only if both the P and Q are true, otherwise it is false always. If we talk about dejection, dejection has just this kind of relationship. If you have any one of true in your P and Q, then it will be true. Any one of true, both true then true, P is true then again true, Q is true then again true, but if both are filled, then only it is false, right? Now, exclusive OR basically works with if we have same inputs from P and Q, then it is false. Only for different input it will be true. Different input means if one is false, second is true, then it is true. If first is true, second is false, then again it is true. So, both the sets must be different, then it will always be true. This is called XOR. Implications basically works if you have if you have Q is false, it is a sequence. If we are using P implies Q, then P and Q in a sequence of P and Q. If Q is false, then only it will be false. Otherwise, it will always be true. Right? The second condition, if false, then only it will be false. Otherwise, it will always be true. I hope you will recognize P implication Q. If we talk biconditional, then here if we have same inputs, either it is true or either both are false, then only it will be true. For different input it will be false. So, it is just complement of XOR, right? In XOR, here these are true and here these are false in XOR, or you can say P XOR Q, right? You can differentiate like this. Statements and operators. So, statement and operators can be combined in any ways to form a new statement. So, negation P again is a new statement, negation Q again is a new statement. If you are having P and Q two statement, then we can say negation P is one statement, negation Q is other statement, and you can combine these statements with the help of different connectives, negation P or negation Q, and you can generate a truth table as per the rule. So, statements and operators can be combined again with different ways like P and Q. You can do it negation P and Q, or you can say it is the same as by opening these operator negation, you will have negation P or negation Q. So, these are the same entries, right? So, what is basically logical equivalence? So, logical equivalence is one of the feature of proposition logic. That means two propositions are said to be logically equivalent if and only if the columns in the truth tables are identical to each other. If we are seeing these two statements, the two tables are equivalent. So, in this way, this is called a logical equivalence. That means these two propositions are logical in logical equivalence. So, next we are taking this example, negation P and Q, negation P or Q are logically equivalent. Again, we can say it is always true for double implication if and only if. We can prove it by using this truth table. We created truth table for negation P and Q, and we created truth table for negation P and negation Q. So, by using double implication, if you find all true, then it is called logically equivalence. So, we know for double implication, if both the inputs are same, means false false, then it will be true. True true, again the same inputs, it will be true. True true, again the same, it is true. True true, again the same, it is true. That means all the entries in this column are true, then it is called logical equivalent with the help of double implication or biconditional statement. So, we can say this statement is logically equivalent to this statement, or this is called tautology, right. Now, there are some algebra propositions. Already you have studied in algebra. The same propositions algebra is here. Commutative property means P and Q will be equivalent to Q and P, or P or Q will be equivalent to Q or P. Associative property will be associated to this AND operator and OR operator, right. And identity means P and true, it will always be true, and P or true will always be true. P and true, that means will be P, well depend upon on the value of P. But if P or depend always, if there is one true, it will always be true. Distributive property, you are distributing this operator over OR and you are distributing this operator over AND. De Morgan's law basically apply as a complement law. So, it will convert your negation and operator will be changed, AND to OR and OR to AND. Double negation will give you eliminate the operator property, right. So, it is negation of negation P will be equivalent to P, right. So, if we talk about tautology, so tautology basically works if statement that is always true, a statement that is always true is called tautology. So, we have already given this table earlier and we find that it is always true. So, it is always true and this will be called as a tautology. If we talk about the contradiction opposite to the tautology, it is always false. So, if we do a tautology with the negation or tautology, it is always contradiction, right. It will be always false 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 in your truth table. Satisfiability, basically a proposition is satisfiable if its truth table contains true at least once. True at least once. If you go P and Q, it is true at least once, right. Tautology is always true. So, contradiction, tautology, contingency, these are some rules of propositions. Contingency is if it is neither true, neither tautology nor contradiction, then it is called contingency. I hope you understand the theory of logic and operators used in this chapter. Thank you very much.